Okay, this is a quick presentation on practical radio telemetry systems for industry. We've got all the slides will be provided, and the topics that we're going to cover are detailed in the sections below. We run these courses every 2 weeks, and the typical thing is to understand radio telemetry systems jargon, perform simple path loss calculations, and obviously talk about troubleshooting radio telemetry problems. So everything's detailed in the slides, but obviously you need to go through those. So the trick is just talk about the fundamentals, data communications, cellular radio, and the protocols. So those are the sort of issues we're going to talk about. And a little bit ambitious trying to cover 80 slides in 40 minutes, but I'm sure that you'll be able to get some idea, some benefit by actually looking at the slides later. So basically the stuff we're really going to be looking at is the radio link, radio spectrum, focusing on UHF and VHF, briefly going through some of the terms used, which are dBs, gain and loss. Some of those who are not familiar with dBs, you'll find described here, but all the calculations are done with the log decibels. Some of the issues with propagation of radio waves, frequency, impact. In other words, if you're using UHF, you can get a higher speed, but you may find that you've got problems getting through forests and lots of difficulty there, whereas VHF, you're probably more likely to penetrate objects. Terrain type will be impact, time of day, weather conditions, moisture, antenna height. Obviously, the higher your antenna, the more likely you're going to be able to transmit, and obviously antenna types and polarization. So these are all covered in the materials. Summary of the VHF bands and UHF bands. The other issues are spread spectrum, which is a new approach these days with a wide range of frequency used, extremely secure. The other issues are intermodulation, which you can have a potential problem. Those that work in the electrical industry will be familiar with harmonics. This is a similar problem where you obviously get different frequencies interacting, say on a rusty bolt on a radio mast, and of course that does have potential problems. We need filtering to eliminate that. We detail the steps in implementing a radio link here using your contour map first of all. Looking at the K factor, where you need to apply that because the world is actually, the Earth is actually curved. We need to do that. And then effectively what you end up doing is getting a spreadsheet calculation like this. This will be put into a spreadsheet, this list here, where you work out your fade margin, and this consists of free space loss, fraction losses, which are negative, transfer power, receiver sensitivity, antenna gain at the RTU, and then obviously take off your cable and connector losses, multi-coupler and duplexer losses, and then add in your receiver preamp gain. This is all done in decibels, so you can add or subtract without any problems with the nightmare multiplying or dividing. Then we talk about data communication links, RS-232, 485. As I emphasized, 485 is obviously the way to go. You may also use an industrial Ethernet connection, which is very good for harsh environments. Troubleshooting Ethernet, some of the issues here, multimeters, all the way from physical to protocol analyzers, hardware stuff. I've already listed all the items there. We've covered this in other webcasts. Under cellular radio data, just want to emphasize the use of GPRS, GSM or GPRS, which is used quite extensively. And then you've got the issue of protocols, and obviously the three protocols that you really want to spend time on are TCP/IP. And you can see the structure there, Modbus, which is a very old protocol, which is still widely used. And then finally, DNP3. So that's covered. And then, of course, DNP3 and Modbus all go with TCP/IP. So that gives you a quick summary of the presentation in a nutshell. Over to you guys. Please look at the slides. They do have a very detailed summary.